All right, our last video for this lesson is going to just be about finding trig values when you're given information about an angle. So to just start kind of thinking along these lines, I want to answer two quick questions here. They're about quadrants, right? So if cosecant is greater than 0, what quadrants could theta lie in? So remember we have our handy mnemonic. All students take calculus. So cosecant is the reciprocal of sine. So it will be positive, positive in any quadrant where sine is positive, where sine is positive. So they are all positive in quadrant 1. So it could be in quadrant 1. And sine is positive in quadrant 2. So those are the two possibilities for where theta could lie if its cosecant is positive. How about the second question? Same idea, different information. So this time we are told that the cotangent is positive. So cotangent, positive. Where is that going to happen? Cotangent would be positive. Well, everything's positive in 1. And tangent and cotangent are positive in 3. But then we are given an extra piece of information that secant is negative. So secant is the reciprocal of cosine. So of these two quadrants, which one would have a negative cosine? 1? Nope, everything's positive in 1. 3? Yes, only tangent and cotangent are positive in 3. So cosine and secant will be negative. So it can't be 1, it must be 3. Okay, just kind of getting you to start using some of the information that we know, that we've learned about these ratios in different quadrants. So one advantage to using, many advantages, but one of them to using triangles over the unit circle is that you can just draw triangles to find trig values. And a lot of times when people use the unit circle, they end up getting stuck using identities to solve everything, which quite frankly is a lot more work. So here's what we're going to do. We're going to determine the quadrant of whatever angle we are given. We will draw in the reference triangle and label the sides given what information we have, and then find the requested ratio. It's pretty straightforward. So just going to do a couple of these. So given that cosine is 4/5 and theta is in quadrant 4, find sine and cotangent. Okay, so I don't have to do much digging to figure out what quadrant it's in. They told me. So I'm just going to go ahead and draw that reference triangle. So if it's in quadrant 4, I mean, technically I might assume that that angle goes like this, right? But for my triangle, I always want to use the reference angle between the terminal ray and the x-axis and drop the perpendicular to the x-axis, always. So now I have a quadrant 4 angle. I'm going to use this piece of information. Cosine is 4/5. So from this angle, cosine would be adjacent over hypotenuse. Adjacent over hypotenuse. And so now if I just use the Pythagorean theorem here, I can find out that y is 3. And so I'm going to fill that in. Now, some people will put a -3 here because the y is down. It's in the negative direction, right? We're doing positive x, negative y to get to the 4th quadrant. Some people will not. They'll just label it as 3, and then they'll keep in mind they're all students take calculus. So since we're in the 4th quadrant, I know that cosine and secant are positive, right? So if I'm going to be finding sine, that will be negative. And if I'm finding cotangent, that will be negative. So as long as I account for my negative in some way, shape, or form, whether it be labeling the side negative or I just do it this way where I write it down first. And then I go to my triangle. Sine would be opposite over hypotenuse. So 3/5. Cotangent would be not TOA, but the reciprocal of that. So adjacent over opposite. So 4/3. Right, so again, I might just handily write this down at the top of my page so I can use that opposite over hypotenuse, adjacent over opposite in that case. Pretty straightforward, right? It's not too hard. So there's two more. I want you to give them a try. Go ahead and pause the video and see what you can make of them. All right, let's take a look. So in number 2, I was told that theta is in quadrant 3. So I drew it in quadrant 3. I dropped that reference triangle to the x-axis. So here's my reference angle. The tangent is 12/5. So tangent is opposite over adjacent. That means I knew the two legs. And I went ahead and used the Pythagorean theorem to find the hypotenuse. Now, in this case, this time I left everything as positive, but I know that tangent and cotangent are positive in the third quadrant. So both secant and cosecant will be negative. And then I just went ahead and looked at secant. Well, that's the reciprocal of cosine. So it'll be hypotenuse over adjacent. And cosecant is the reciprocal of sine. So it will be hypotenuse over opposite. Similar setup for number 3, also in quadrant 3. This time the sine is negative 15/17. So I drew my reference triangle the same way, opposite over hypotenuse. We always consider the hypotenuse positive if you are attaching the negatives. It's a negative x, a negative y, but the hypotenuse is always positive. Okay, if you're going to use that convention, then you need to make sure this is always positive. So the negative goes with the 15. Opposite over hypotenuse. Once again, use the Pythagorean theorem to find the missing side. This time, instead of using my all students take calculus, I labeled my x and my y's as negative since they're in the third quadrant, and then used my picture. Secant is hypotenuse over adjacent, and tangent is opposite over adjacent.